Python. Now what we're actually going to be doing is what you see here. And it's actually not that challenging to do. The key thing here though is to understand that there's all these different techniques that you can apply to your OpenCV projects to make them cooler or more useful. So let's go ahead and jump into the code. All right, so now in filter_lesson.py, we are going to start making our filters. Now, of course, the filters themselves are really just going to be methods that we implement that we can play around with at any time. One of the easiest filters to do is to just have an inverted image. So let's go ahead and do that. I'm going to make a method called apply invert, and it's going to take in the frame. And all it's going to do is return something called bitwise not. So bitwise not of that frame. And we'll just go ahead and say frame equals to apply invert of frame. In fact, let's actually call that invert. And what I will say is if you run into any issues with the processing speed of things, make sure you get rid of print statements and make sure that you don't have too many of the frames being shown or even processing too many of them. But now let's jump into our command line and I'll run Python filter_lesson.py, hit enter, and there we go. There is an inverted picture of me. So everything that's sort of dark is now white. And, you know, it's the negative. It's the negative of the picture. So we could actually print out this negative if we wanted to. But it's a very simple filter. I don't know exactly what you would use it for, but it does exist and it was super easy to do. So all it did was it inverted every pixel value inside of this bitwise not. So that's all it's doing is it's just literally inverting those values. And of course, if I did the invert of the invert, what should we see here? This is a silly thing to do, but it gives me that original color. This is actually real color. But that is something we won't ever really do, is have an invert of an invert. It doesn't make a whole lot of sense there. So the next thing that I want to do is I want to apply the sepia color. So sepia is a popular thing that makes sort of like old-timey photo look, but we'll see what that is in just a moment. So we'll call it apply sepia, and again it takes the frame, and this time we're going to pass in an intensity level. I'll explain this in just a moment, but we'll pass in it at 0.5. And then the first thing that I want to do is I want the frame to be an alpha channel, right? So what I can do is I can say cv2.convertColor, and that's the frame, and cv2.color_BGR2 BGRA. So we want that alpha channel in our frame. So normally we have only 3 channels, and the 4th channel would be that alpha channel, right? So if we want it to be more transparent, then we will change the alpha channel to some degree. But it's not really for the frame itself, it's for what we need to do to the frame. So that means I need to grab a few things about the frame. So I'll say frame_H, frame_W, and frame_C. And it's going to be the frame shape. So frame height, frame width, frame channels. So right now it should be related to what I said here, right? So my 480p should be, I believe that will be my width, but let's just take a look at it just to double check the size, frame H, and frame height. And then I'll also just go ahead and return the frame. Okay, so one thing I want to mention before we actually even run this or even look at it, this is not going to display. The reason it's not going to display is because we still have that alpha channel. So I actually need to turn the frame back into just into BGR. So cv2.convertColor frame cv2.color instead of BGR to, or well, just basically just like that. So BGRA to BGR. So then now down here, I'll comment the invert one out and just say that sepia equals to apply sepia. And I'll use frame.copy now. So frame.copy will mean that, you know, if we ever made some changes to the frame, the original frame, we can just copy it, and now it's kind of working off of a new version of that original frame. And then we'll just do mcv2.mshow, and that's sepia and sepia. Okay, so we'll save that and we'll run it. And of course, there we go. So we have 480. Oh, whoops, I didn't print out both of them. So width and height, 480 is the height, and then the width will be 640. Cool. So we've got the width and the height, and then the number of channels. In our case, it should be 4. I'll let you test that out if you're so interested in. So I actually might have this occur sometimes, right? So I might have this come through a few different times. So what I'm going to do is just make a verify alpha channel, and we'll say frame, and I'll just go ahead and do try frame.shape 3, and then we'll do accept index error, and we'll do that same conversion right here, and then we'll return the frame. Okay, so this is really going to give us a try exception on if it doesn't even have an alpha channel at all, or it doesn't have a third channel at all. It will then give us, or rather that's the 4th position. So if there is no alpha channel, which is what this is doing, it will create one for us. And then we can pretty much do the reverse of that with converting it back, but I'll just make sure that I have it converted back just so I see it. And now I'll just go ahead and do verify alpha channel instead. And that way I can know that, hey, yeah, for sure there's an alpha channel, because I will definitely use this again. Okay, so this is a long-winded way to pretty much do something you may have seen before, and that is in watermark.py. So what we did in watermark is we created this alpha channel, we got the frame, then we created an overlay, and then we actually changed specific pixel values with that overlay. But in our case, with sepia, our overlay is quite literally going to be the same as the frame, or the same size, but it's just going to be an entire color overlay. So we just need to fill it with a certain color. That's it. And to do this, we're going to use something called sepia BGRA, or in other words, we're essentially making what the BGRA values will be. So that's blue, green, red, and then what our alpha value will be. In our case, we're just going to leave it in as 1. We'll change it in a moment when we do the actual blending, but initially I'll just keep it in as 1. Okay, so what is blue going to be? Well, blue is, I mean, you can play around with these values. These are not hard, fast rules, but I'm just saying blue is 20, and then green is equal to 66, and then finally red is equal to 112. So those are also, if you look at them in reverse, those are the RGB values for the sepia color, if you will. Okay, so now that I've got those, I can create an overlay, and this overlay is going to be called mp.full. So where we did in watermark, we did mp.zeros because we wanted everything to be zeros identical to the frame. So we don't want that anymore. We want everything to be the sepia color identical to the frame. So to do this, we're going to do frame_h, frame_w, 4 for that alpha channel. And then finally, we will add in the sepia BGR that we just added. And then finally, the dtype equaling to uint8. The dtype, or the data type, that is actually important for when we do the cv2.add weighted. And that's going to be our overlay. Our intensity. So how intense do we want this overlay to be? Now, it's going to be the full sepia color, right? So that's what this is doing, is it's making that full sepia color for the entire frame. So we want to decide on how intense we want that to be. So the higher this number is between 0 and 1, the higher that number is, the more intense of a value it will be. We'll play around with that in a second. And then we're going to add this to the frame, or we're going to blend it with the frame, and we're going to put the frame at 1.0 with 0, and then the destination or the final frame is what's going to be passed. So this last part is critical too. This first part is doing that overlay with its intensity, and then it blends to the frame. So this is going to be what's underneath it with whatever that intensity is. And then we finally have that destination of frame. And then I converted the color back to BGR and then frame. So now all of the sepia related stuff should run. So let's go ahead and do it. And there we go. So that is a sepia color. It might be a little bit hard to tell because I don't have the frame showing itself. So I will go ahead and put it in there too. So CV2 show and frame, comma frame. So of course this is the normal frame color next to the sepia frame color. All right. So what that means too is that I can play around with its intensity. I told you I'd do that. So if I put it to 0.8, now it's a little bit more of an intense sepia color. If I put it down to 0.2, it's going to be even less. It's super light. It's almost impossible to even tell. So what you may have noticed, maybe not, is the similarity of sepia as to what we could do with just any color overlay. It doesn't necessarily have to be sepia. So I'll go ahead and copy that, paste right above, and just say apply color overlay. And then we're just going to, instead of having these values in here like this, hard-coded in there, we can pass them through as arguments. And that's what I'll do. So I'll pass them in here as arguments that we can change whenever we want, whenever we're calling this apply method. Okay, so now instead of sepia BGR, I'll just give it as color BGRA. There we go. It's the same exact command. So actually, this part will literally just be, well, we could come in here and comment all of this out and apply this same thing. So we could say frame equals to now apply color overlay frame, the intensity being equal to the past intensity, right? So we're passing sort of two levels of intensity here, and then blue equals to blue, green equals to green, and red equals to red. So you can do it that way. This is valid. This is actually what would be a better way of doing it than what I did originally. But I just wanted to show you that, yeah, maybe you want to have some default values for blue, green, and red, and that's how you would apply sepia that way. And then if we wanted some other colors, I'm not really sure another sort of filter that you might want to have, but we'll just say reddish color, and then I'll just say apply, what do we call it? Color overlay. And we'll call this reddish color. So now with the apply color overlay, we can add the intensity being, 0.5, and then red being, what value of red do we want? Well, it's going to be between 255 and 0. So I'll give it a 230 and then a blue of 10. And then I'll come back up to my overlay color. The defaults I'll just put in as zeros. So we save that. Let's run it again. And there's my reddish now hue or color to all this, right? We still have a sepia color, which is not a hugely intense one now. So let's change that back to having a default of 0.5 and run it again. And there we go. So that's now I have these different colors on these frames. Now, why would you do this? I mean, there's artistic reasons for it. It's just about also learning a little bit more about OpenCV in the sense that this might help you with pre-processing your data. You might be able to use these different filters to find various things in your data. That's another reason that we're doing this. But it's also just kind of fun. It's kind of cool. It's kind of cool to see what you can and can't do with OpenCV. Okay, so I'm going to go ahead and comment those ones out as well because we're not quite done with these filters. Now what I'm going to be doing is a little bit more of an advanced filter. And that is doing this a circle focus blur. So the circle focus blur is going to give us a little blur. So we're going to do a circle, we're going to make a circle, and then we're going to have a blur on the outside of that circle. So it's a little complicated. I'm going to go ahead and write out the code. I'm going to copy and paste the code over from the actual live version, which is in filter. And I copy and paste it over because it is a little bit complicated on how this works. So I'm just going to go line by line and sort of explain it versus writing everything out. Okay, so first we've seen our alpha channel that we've already done. We've already done that part with the shape of it. And then we're going to get the y and x values. So in order for us to draw a circle, I want that circle to be right in the middle of our frame. So that's why we get our y and x values. So the y value is the frame height, right? So we want that divided by 2. And then the x value is the frame width divided by 2. Now, we want to know where the center point is. So I can say center point equals to the integer of, we could do y divided by 2 or the integer of x divided by 2. Both of those are actually roughly the center point of those axes, right? But I'm going to use y. I'm going to use y as my center point, which is actually going to be my radius. So this is actually my radius for my eventual circle. You might see this down here as to what it is. So the real center point is where these x and y values are. So center equals to the x and y value. Not center, but center. So we can replace some of these in our circle, and that will give you a better idea of how this circle is looked at. So we've got our center value and our radius, and then we have a mask, which we've seen these masks before. In this case, we're calling it a mask, but it's still the same as our overlay. So scrolling and looking at our overlay, instead of MP full, we're using MP zeros, and it's the same thing. It's still that alpha channel, same data type. And in this case, we don't actually put any color in because we're using zeros. We're using NP zeros. So we didn't put any color in there. If I wanted to add color, I could, but I'm not going to. Next, what we do is we actually create the circle for that overlay or that mask. In this case, again, it's a mask. So that creates it, and then we blur it out. So let's actually take a look at what that looks like. So I'll do cv2.mshow of the mask. And I will just keep things like this. And we're going to go ahead and come down here and we'll call it circle blur. Apply circle blur of the frame and cv2m show circle blur and circle blur. Okay, so let's save it and run it. Requirement argument mat. Oops, we probably have a... yeah, so mask, this should say mask. So we need to include the matrix. That's what that it's looking for, the NumPy array, which is a matrix. So we do this. Oh, we got blended is not defined. Oh, yes. So this, let's just call that frame. We commented some things out. Okay, so this is our mask. So notice how it has a soft line on the outside. That's from this blur. So once we added that blur, it created this mask. So essentially what I'm doing is I'm going to put my face in here, and that will be clear, and then everything else will be blurred. And to do this, we use the blurred image of the frame itself, so we can see what that looks like. Let's take a look. Save that and run it. Okay, I've got a few different things going on here, but there's the blurred image. So essentially what I'm doing is I'm going to be placing my face behind this circle, and then that circle will have clearness, and then the rest will be, you know, just blurred out, just like this one. So to do that, all we have to do is this alpha blend item, where it sort of blends the two things together. Okay, I'll explain that in a little bit more in just a second, but I'm getting rid of these image shows because we don't need them anymore. So what it's doing is it's taking the alpha. So the alpha, or rather it's making an alpha based off of the mask. So the mask being that we want to get rid of all of the values at 255 or white, right? So we want to divide everything by that white, so it allows us to then, multiply or blend these things together based off of the first frame and then the blurred version of that frame. So let's see. Another way to look at this is essentially saying that we're passing the original frame in, and then we're passing the blurred frame in, and then we're adding the mask to that. So the original frame, we are getting the inverse of that original mask. In other words, we are taking where white is and we're making that the frame. And then the other part of it is adding in the second frame and getting the black part and turning that into a blurred image. So the second frame, of course, is that blurred portion. So I realize that's a little confusing. Literally just play around with it, play around with your different masks and all that to hopefully make a little bit more sense. I learned it just from playing around with it. So that's how I kind of made sense of it. Anyway, so we run this filter again, and now what you see is blur, right? So not blurry, blurry, which is kind of cool. So it actually shows me a little bit of this blurriness that I can add to my circles, right? So if I change the radius of the X value, then, or the circle itself, then it's probably a little bit of a bigger circle. But notice that it's a soft blend. It's not a hard blend. It's not like, you can't really tell there's a line. I mean, you can tell, but it's not like a hard line. That has to do with the values that we use for blending, as well as that alpha blend that just allowed it to happen. Okay, so now how do I take this one step even further? And how do I do it where it's essentially taking my outline, which will work better on like a white background with my different color. How do I take that and apply something almost like a portrait mode? So I'm going to go ahead and copy and paste the code again. And here is our portrait mode code. So what we're doing is we are taking the original frame, we're converting it to gray, and then we're looking at a threshold. And now this threshold is actually going to be our threshold mask. So to see that, we'll do cv2.imshow the mask of the mask. Okay. And then down here, I'll comment these out again. And then bring in, well, I'll go ahead and copy them and comment them out. There we go. And bring in this portrait mode, or let's call it apply portrait mode. Okay, and then apply portrait mode, and then just call that portrait mode. And like many things, I'm gonna go ahead and leave these out for a moment. And the frame, it doesn't look like I even convert the frame anywhere. So I'm going to go ahead and leave that one out, as well as take off this imshow. Okay, so we'll save that and let's run it. Okay, so we're getting oh yeah, this needs to be not a string, but the actual threshold itself. Okay, so there's my threshold. So this right here is showing the threshold values for this gray color. So what it's looking for is the grayscale, and it's converting it into white or black, right? So I can change these values, let's say to like 50, anywhere between 200. Oops, let's close that out. Looks like it's not wanting to close. Okay, so we'll try that again. And that changes it a lot, right? So I actually missed some of the actual color. For some reason, it's not wanting to close out. It missed some of the color, and that's why I left it at 120. Okay, so then we apply that same concept from above to this mask, right? So I actually grab what this mask is, I turn it into my alpha values, and then I run it. So let's go ahead and try this out. Now, we want to let's see, a couple things. Could not broadcast together. Okay, so hopefully you have an idea of what's going on here, and that's the frame itself should be also verified alpha channel. Run that again. And now I see three different things. So I have my threshold actually there. And then this is my sort of portrait mode. I mean, it's actually not that great, but what you'll see is if I hold something up behind me, here's a hard drive. If I hold that up behind me, it actually gets more blurry. This is going to take some time to play around with. Now, it's not a true portrait mode. A true portrait mode would actually allow you to, you would actually use two different cameras, and that will help that depth. But what I did here was actually use the threshold value of my color and allow that to sort of play around with the portrait mode. It was just sort of a way to show you just generally something that I've been playing around with myself on how to apply some sort of portrait mode. Okay, so that's all of the filters. I'm going to go ahead and try and run them all now and see if we can just take a quick look at them and what we learned. And then let's make sure that all of the other shows are no longer being shown on any of our actual methods. In general, you'll probably want to have those shows on this main loop because it's going to be easier to point out where things go wrong. Okay, so we save it and we'll go ahead and run it. And there we go. So we have various different filters. The last thing that I want to challenge you to do is take this circle blur one and make it move based off of the face that's in it. So adding the blur with a square and all that, it might actually take some processing power from your machine. So do keep that in mind. I mean, even me running these 5 videos right now, or these frames, they're actually off of my voice. So like I'm looking at it and it's off of my voice. So there is a little bit of a lag. So if you see that lag, it's definitely an even bigger lag. But that's it. I mean, we played around with a bunch of things, and I do encourage you to play around more because that's what OpenCV is all about, is to play around with it so you have a better grasp of what's going on. And if anything wasn't exactly that clear, please let me know. Hey, thanks so much for watching. My name's Justin. I'm the one who helped you through this, hopefully. The purpose of these tutorials is to help you speed up your learning process with a variety of things. And we have a lot more on joincv.com/YouTube. Not just for OpenCV, but for all kinds of web development topics. We want to help you learn more code so you can make things happen faster. So please consider subscribing, hit that bell for notifications to get everything, and I look forward